Okay, so yesterday we looked at finding the length of a line segment, and today we're going to look at working backwards with the distance formula. So we're going to have the length of a line segment, and we're going to work out a coordinate, one of the coordinates that are missing of a point. So this question number 1, you're given 2 points, P and Q. P is negative 5, 6, Q negative 9, Y. We're looking for the value of Y if PQ is equal to 5 centimeters. So here we've been given the distance, PQ. All right, so because we've been given a distance, we're going to start with the distance formula. So the length of PQ is equal to the x at P minus x at Q plus the y at P minus the y at Q squared. Okay, and then here are my points, and we're going to substitute them. And we're also going to substitute the distance. So I can fill in the distance as well because I have the distance. So here I put in a 5 for the length of PQ. On this side, we've got the x at P minus the x at Q. And then we have the y at P, 6, minus the y at Q, which is just a y. All right, so now what I'm going to do is I'm going to have to solve this equation. So we need to solve this. So the first thing I'm going to do, because it's one term on each side, I'm going to square both sides, because that's going to get rid of the square root sign. All right, so let's do that. So we're going to square this side, and we're going to square this side. All right, so let's see what happens now. 5 squared is 25, and the square root squared, these two would cancel each other. And you would have negative 5 plus 9, which gives you 4 squared. And this is 6 minus y. Unlike terms, you're not going to be able to add those, so we're going to have them like that. Okay, now we need to simplify. We need to remove the brackets. All right, so 25, no brackets there. 4 squared, this is one term, so I can just square it, and I'm going to get 4 times 4 is 16. Remember here we have 2 terms, so you either need to think of 6 minus y as being 2 brackets the same multiplied together, and you're going to FOIL it out, or you're going to think of your shortcut, square the first, twice the product of the two, square the last. Whichever way you do it, you cannot bring your square into this bracket because you have 2 terms. Okay, so I'm going to do it the long way around. It's a positive 1 in front of my bracket, so I can multiply straight out. This is going to be 36 minus 6y minus 6y plus y squared when I use FOIL. Okay, if you did it the shortcut, you'd have 36 minus 12y plus y squared. All right, then we're going to get our like terms together. So 25, nothing to go with that. Those two can go together, and the y's can go together. Okay, so I've got 16 plus 36, which is going to give you 52, minus 12y, negative 6 and negative 6 give you a negative 12y plus y squared. Okay, what kind of equation is this? It's quadratic. It's got a y squared. So you have to have everything on one side equal to 0. That's what we learned in the first term. Okay, so I'm going to do, the easiest thing would be to move the 25 from this side to that side. Okay, so we're going to have 0. And remember, it's got to be in the right order. So it's going to be y squared, then your y's, and then we're going to have 52 minus 25, which is going to give you 27. Okay, now if you remember from your quadratic equations, you have to factorize. Okay, so I'm looking for numbers that multiply to give 27, and add to give 12. Okay, so 27 could be 1 times 27. Let's just do that in another color. 3 times 9. Oh, there we go. Those two numbers multiply to give 27, and they add to give 12. So those are my two factors that I need. Y and 3, y and 9. And our signs have to be the same because it's a positive 27. So it could be positive and positive, or negative and negative, and the negative 12 tells you it must be a negative and a negative. Okay. Now we need to use our zero product rule. Okay, so y minus 3 must be 0, or y minus 9 must be 0. And then you solve each little one. So y could be 3, or y could be 9. And those are your two solutions that you can have for that equation. Okay, let's try another one. The point A, x1, is equidistant from the points T and B. Find the value of x. Okay, equidistance just means they are the same length. Same distance, same length. Okay, and in this little diagram on the side here, I've shown you that AT and AB are the same length there. All right, so what do I know? I know that AT has to equal AB. But I don't know the length of AT, and I don't know the length of AB. So let's just write these on here. I'm going to find the length of AT, and I'm going to make it equal to the length of AB. So how do we find the length of AT? Well, it's the x at A minus x at T squared plus the y at A minus the y at T squared. And how do I find the length of AB? Well, the x at A minus x at B squared plus the y at A minus the y at B squared. So there's my distance formulas, making the two lines equal. Okay, so we're going to fill these in from our information we have at the side here. All right, so what is my x at A? Well, it's just an x. Look up here. Here's my x at A. It's just an x there. Okay, the x at T is a -2. Y at A, 1. Y at T, -1. So that's all the information from A and T. Now we look at A and B. Okay, again, x at A is an x. X at B is a 1. Y at A, here it is here, a 1. Y at B is a 2. Okay, again, these square root signs make one term on each side. So after we've substituted, we're going to square both sides to get rid of those square root signs because it's one term on each side. Okay, so we're going to let's square this side, And let's square that side. Okay, so the square and the square root would cancel each other. So now we're working on the inside. What have I got here? I've got x plus 2 squared, because the negative and the negative make a positive there. And on this one, I've got 1 plus 1, which is going to give me 2. Okay, those are cancelling. What's inside my bracket? Well, nothing I can do with that right now. Here, I've got 1 minus 2, which gives me negative 1 squared. Okay, now we're going to remove our brackets. Remember, if you have two terms inside, you've got to FOIL them out or take the shortcut. Okay, so we're going to write this twice, or you're going to go square of the first, twice the product of the two, square of the last. That's going to be 4. And again, you can square it out. Okay, you just can't bring your exponent in because it's two terms, okay? So either write it twice, or do square the first, twice the product of the two, square the last. And this is negative 1 squared, which gives you 1. Okay, so this is going to give me x squared plus 2x, which will give me my 4x plus a 4. And then this 4 also needs 2. So these have been FOILed into x squared plus 4x plus 4. This will give you x squared minus 1x minus another 1x, which gives you negative 2x plus 1, and then plus that 1. All right, like terms. Okay, so don't forget to FOIL your brackets out. Look for like terms. So on the left-hand side, my 4 and my 4 give me an 8. And on the right-hand side, my 2 and my 1 and my 1 give me a 2. Okay, this looks like a quadratic equation. But can you guys see that if I subtracted the x squared to move it to this side, it would actually cancel? So it's not actually a quadratic equation. Your x squareds cancel. It's just a normal linear equation. So we want our x's on one side and our numbers on the other. Okay, so we've got 4x plus 8 is equal to negative 2x plus 2. Let's move the things over. We're going to subtract the 8 to get it on that side. And we're going to add that 2x. Because it's a negative 2, we do the opposite to get it on the other side. Okay, inverse operation. So that's going to be 6x. And that gives you 0. And that's a 0. And that gives you a negative 6. And finally, we've got one term on each side. So we're going to divide both sides by 6. And in this example, x is equal to negative 1. Okay, one more quick one. If I told you that A was 2, 5 and B was negative 1k, and find k if AB is 5 units. So again, what have I been given? I've been given the distance. I'm looking for one of my coordinates. It's a y coordinate there, but they've just called it k. So we're going to start with our distance formula. X at A minus x at B squared plus y at A minus y at B squared. Okay, and remember this is XA, YA, X at B, Y at B. All right, so AB again happens to be 5 units. I'm filling in what I know. It's 5 units long. Substitute on this side. So this will be 2 minus 1 squared. Y at A, 5 minus y at B is a k squared. All right, and we're going to square both sides like we did in the other example. Okay, and we're going to substitute. Okay, so we substituted and we square both sides. All right, so here we go, squaring both sides. Remember that and that would cancel each other. So what do I have? Again, I happen to have 25 on this side. 2 plus 1, which gives me 3 squared. Negative times a negative is a positive there. And remember with this one, you either square the first twice the product of the two, square the last, or you write it out twice and you FOIL it. Okay, so we're removing the brackets. Right, so this will be 25, this will be 9, and then this, remember you have to FOIL out. Okay, so we've got 25. Negative 5k and negative 5k will give you a negative 10k plus a k squared. Are there any like terms? Yes, there are. We've got a 9 and a 25 on that side. So that gives me 34 minus 10k plus k squared. All right, now we need to solve the equation. What kind of equation is it? Okay, we have a k squared, and if you have a square, then it probably is a quadratic equation. So you want everything on one side and a 0 on the other. It doesn't matter which side it is, as long as you've got a 0 on one side and everything else on the other. So I'm going to be moving this 25 over to that side so that I end up with a 0 here. 34 minus 25 gives me 9, but remember, what's your order, hey? You want to have your k squared first, then you want your k term, and then you want your constant. So it's your k squared, your k, and your constant, so that you can factorize it. Okay. All right, so I need to factorize. So we've got numbers that multiply to give 9. 9 times 1, 3 times 3. But they've got to add to give 10. So it has to be the 9 and the 1. All right, so we've got k and 9, k and 1. And again, we have a positive 9, so it could have been a positive with a positive to get a positive, or a negative with a negative. And this negative 10 here tells me it must have been a negative 9 and a negative 1k to give me a negative 10. Okay, 0 product rule. Okay, you can only use this, remember, when you have a 0 on the one side, and we do have a 0. So we say, all right, we say that k minus 9 was 0, or k minus 1 is 0. And now we just finish by solving normal little linear equations now. So we add the 9 to both sides, add that 1, and we end up with k is equal to 9, or k is equal to 1.